In this video, we are going to teach you how to remember electron configuration order. To remember electron configuration order, you need to remember this. You know that you usually distribute electrons to different sublevel, S sublevel, P sublevel, D sublevel, and F sublevel, right? Okay, so you are using just 4 sublevel. So if you draw a box like this, then look, and I will just take 4 box here for 4 sublevel, and then I will just expand this box, right? Look, I am just expanding this box. Okay, so now I can draw a line like this. Okay, in the middle of an atom you get nucleus. Around nucleus you get shell. Then this is our first shell or first energy level. Then this is our second shell or second energy level, right? First shell has one subshell, that is 1s. Second shell has 2 subshell, 2s, 2p. So look, 1s, that is in first shell, will write the value of n here, right? 1s in first energy level, then 2s, 2p in second energy level. In third energy level, look, we'll get 3s, 3p, 3d. 3s, 3p, 3d. In fourth energy level, we'll get 4s, 4p, 4d, 4f, right? In 5s, in fifth energy level, we get 5s, then 5p, 5d, 5f, right? We usually don't use the subshell after f. Then we can expand this, right, according to our need. Here we can write 6s, 6p, then 6d, 6f, then 7s, 7p, 7d, 7f, right? Okay. Now to get ground state electron configuration order or electron configuration in order of energy, you have to draw a line like this. You have to draw a line around 45-degree angle. You know that this line and this line is perpendicular to each other. This is 90-degree, but if you draw a line like this will be 45, this will be 45, right? So you have to draw a line around 45-degree angle. So we are getting here 1s, then we are getting here like this 2s, that is energy is increasing. Okay, after 2s we are getting like this. 2p 3s, at first 2p then 3s, then we are getting here, look, 3p 4s, 3p 4s, then we are getting here 3d 4p 5s, then look here we are getting 4d 5p 5s, then look here 4f, right? Then we need to write 5d 4f, then 5d, then 6p, then 7s. So this is the ground state electron configuration order in increasing energy. This is the correct order of increasing energy for writing electron configuration. Okay, look, energy is increasing in this way, right? So we can apply another rule to find this sequence of subshell for doing electron configuration. So look, we know that in first shell we have one subshell, that is 1s, then in second we have two subshell, 2s 2p, right? In third shell we have three subshell, 3p 3d, right? Then in fourth subshell we have 4s 4p 4d and 4f, fourth subshell. So we'll find the energy of this subshell by n plus L value. Look, L, the value of L 0 1 2 3, the value of value of L indicates S subshell, 1 indicates P subshell, 2 indicates D subshell, 3 indicates F subshell. So the energy of this 1s subshell will be 1 plus 0, that is 1 plus 0 means 1. The energy of this 2s will be 2 plus 0 2, and then we'll get this 2 plus 1 3, then 3 plus 0 3, and 3 plus 1 4, 3 plus 2 5, 5, then 4 plus 0 4, then 4 plus 1 5, then 4 plus 2 6, then 4 plus 3 7. So look, when you will write electron configuration, first 2 electron will go to 1s2, then the second 2 electron will go to 2s2. After since we are getting energy, one after one electron will enter into 2s, then electron will enter may enter these two sub level, but since this two sub level has same energy, So electron will enter into the sublevel that has lower value of n. So the lower value of n is here 2. So electron will enter to 2p. So look, after 1s electron will enter into 2s, then 2p. After 2p the energy of 3 will come here, that is 3s, right? Then after 3s electron may enter into 3p or 4s because the energy is same. From we are looking at the value of n plus l. So electron may go here or here. So how to explain that? So now we're looking for the n value. So n value for 3p is lower. So electron will enter 3p first. So 3p, right? Then 4s, right? After 4s electron will go from here, energy 4, then 5. So but here we have 2 5. So electron will enter into the sublevel that has lower n value, that is 3d, then 4p, right? Okay. Now after 4p, look, in fourth shell we have 4d and 4f left, right? So we can write another 5s, 5p, 5d, 5f. So n plus l value is 5, then here 6, then here 7, then here 8. So here we have 4d, energy is 6, right? But look, in fifth energy level we have 5s, that energy is 5. So electron will enter 5s subshell first, since its energy is lower than this 4d. So 5s, after 5s we will consider this 4d, because if you compare 4d and 5p, then the energy of 4d is lower because of this lower value of n. So thus you can remember the electron configuration order, right, or ground state electron configuration order. I am going to help you to memorize this sequence in more way, right? This is the, I think, the best way you can memorize this thing, right? You know that usually we distribute electron to s, p, d and f subshell, right? So this is your first subshell, second, third and fourth. S can handle maximum 2, P can handle maximum 6, D can handle maximum 10 and F can handle maximum 14. Okay. So look, to remember this sequence, how to write. At first you have to consider this S subshell and you need to write F subshell twice, SS. Then you need to consider these two subshell PS as a unit, and you need to write this unit twice, PS. Then you need to consider this three subshell twice, DPS as a unit, DPS you need to write as a unit, and you need to write DPS twice. So then at last you need to remember this 4 FDPS, this 4 subshell as a unit. And you need to write you can write this FDPS, that is last unit, as you wish. That is, there is no limit for writing FDPS, right? So say with me, SS, PS, PS, DPS, DPS, then FDPS, FDPS, FDPS. Say with me, SS, PS, PS, DPS, DPS, FDPS, FDPS, FDPS. Please say with me, SS, PS, PS, DPS, DPS, FDPS, FDPS, FDPS. So this is the way to remember electron configuration, way to write electron configuration quickly. SS, PS, PS, DPS, DPS, FDPS, 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 right? So now you need to put the value of principal quantum number. S start from 1s, then second S automatically will be 2s, then 3s, 4s, 5s, 6s, 7s, 8s. P start from second shell, that is 2p, then automatically the second P will be third P, 4p, 5p, 6p, 7p. Then D start from third shell, that is 3D, then 4D, then 5D, then 6D. And F start from fourth shell, that is 4F, 4F, then 5F, and if you get, then this will be 6F, right? So this is the electron configuration order in increasing of energy. Energy is increasing, right? So let us show you another way. Sometimes you need to write this electron configuration like this: 1s, 2s, 2p, 3s, 3p, 3d, and 4s, 4p, 4d, 4f. S can hold maximum 2, P can hold 6, and D can hold maximum 10, and F can hold maximum 14. So let us take an example of neon. Neon, the atomic number of neon is 10. This means that it has 10 electrons and 10 protons. Here we are focusing on electrons, so we need to distribute these 10 electrons to different sublevel. So first 2 electron will go to 1s, 1s2, then we need to this 2s2, then 2p, 6. So 6 to 8, 10. So this is the electron configuration of neon, right? Okay, so now we'll do the electron configuration of neon by like this. Neon 10. So we know that SS, PS, PS, then DPS, DPS, FD, PS or FDPS. Actually neon has 10, so we need to distribute this 10, 2, 4, 6, 10, right? We don't need this subshell. So S start from 1s, then 2s, and 3p start from 2p. So this is the electron configuration of neon. Let us take more critical thing. Chromium 24. So how to write the electron configuration of chromium, you can write like this: SPDF. So at first you have to write S twice, then you have to consider this PS twice, then DPS twice, then FDPS. You can write FDPS any number. So 24, 2, 4, 10, 12, 18, 20, 24. So A start from 1s, 2s, 3s, 4s, and P start from 2p, 3p, right, and D start from 3d. So this should be the electron configuration of chromium, but chromium has exceptional electron configuration. You know that D can hold maximum 10. The half of D equal to 5. Look here, the energy of 4s and 3d, if you find the energy by n plus L value, 4 plus 0, that is 4, and 3 plus 2, 5. The energy of 4s and 3d is closer to each other, and D has 4D4 configuration, so it will take one electron from the highest value of n subshell, that is 4s, and it will become D5. D5 is very stable, right? That is why it will take electron from 4s, and its actual electron configuration will be like this. Okay, now I am going to write the electron configuration of magnesium. It's 12, right? I can write the electron configuration of magnesium like this: 1s, then 2s, 2p, then 3s, 3p, 3d, then 4s, 4p, 4d, 4f, right? I will just write this type of sub-level. So now I will find n plus L value. For n plus L, for 1s we get 1 plus 0, 1. Then for the second shell we will get here 2, then 3, 3 plus 0, 3, 3 plus 1, 4, 3 plus 2, that is 5. Then here we are getting 4, 4 plus 0, 4 plus 1, 5. Then 4 plus 2, 6, 4 plus 3, 7. So magnesium has 12 electrons, that is 2. After we are looking at the energy, we will first place electron to the lower energy, then higher energy subshell. 1s2, then second 2 electron will go to this because there is no energy lower than 2. Then we have 3. We have energy 3 in 2 places. In this case, we will place electron to the lower value of n first. So here, so 6, 8, 10, right? Then we need to put 2 more electrons. So we need to put the electron to the second 3 energy, that is here, and we don't need this subshell, right? At last I will delete these things. So this is the third way, I think. So what is the best way to write electron configuration? The best way to write electron configuration is like this. You have to remember this sequence: SS, PS, PS, then DPS, DPS, twice, then FDPS, FDPS, FDPS. That is no limit for FDPS. So thank you for viewing this video. Be well.